Hey everybody, so this is the Test 2 review assignment on MyMathlab. I'm going to work through most of them. Some of the problems we'll skip. Doesn't mean that they're not important, but just for time's sake, we just might not work everything. But I wanted to go through the review. This way you can check and see that you know how you're working the problems and if you're working them correctly. So let's start with number 1. Determine the x-intercept and y-intercept of the linear equation, if they exist. Write the intercepts as ordered pairs. Okay, we have a line. Okay, so to find the x-intercept, as always, we let the opposite be 0. So we're going to let y equal 0, and then we're going to solve for x. All right, let's see, we have 7x plus 3. Let's let y equal 0, 42. And then we just solve the equation. It's pretty basic. 7x plus 0 equals 42. We can divide out. We get x equals 6. That's going to be my x-intercept. But now MyMathlab is going to ask for it as an ordered pair. So that means we have 6 and then y is 0. So that's our first one. Now for our y-intercept, let's see, we're going to let the opposite value be 0, which would be x. Plug 0 in for x, so we're taking the same line. Here we go. And let's solve it. This gives me 3y equals 42. And does 3 go into 42? I think it does. It goes in. Let's see, is that 14 times? I think so. All right, so y equals 14. So let's put over here as a y-intercept. Right, our x is 0, our y is 14. Okay, for number 2 and 3, I wanted to cover these because they're not your normal lines. We're dealing with vertical and horizontal lines. If you notice, number 2 only has an x in the line, and number 3 only has a y. So I wanted to look at these. So let's first look at number 2. We have 2x equals 3. Let's find the x-intercept. X-intercept, we let y equal 0. So let's plug it in. 2x plus 6. There is no y to plug in 0 into. So we just solve it. You can divide out. You get x equals 3. This is your x-intercept. So we would write it as 3, 0. Okay, let's find the y-intercept. Y-intercept, let's see. Obviously, we let x be 0. Okay, if we plug it in, my function is 2 times x, so that would be 0. Plug in 0 and you get 0 equals 6. Okay, that makes no sense. Okay, so when this happens, that means there are none. Okay, so there are no y-intercepts. Okay, so this is an example of a vertical line. So if you think about it, we have an x-intercept at x equals 3. But there is no y-intercept, so this is an example of a vertical line. Okay? So now let's look at number 3. This only has a y in it, so this is going to be an example of a horizontal line. But let's go through the steps. So we're looking for x-intercept. Letting y equal 0. Let's plug it into the function. The function, we can plug a 0 in for y. And once again, just like the last one, 0 does not equal -8. That does not make any sense. So there is no x-intercept, right? Or none. Okay? The y-intercept, we're going to plug in 0 for x. If we plug that in, we have -2y. There is no x, right? So there's nothing to plug 0 into. So let's solve for y. Divide out by -2, we get y equals 4. So we actually have a y-intercept. So we would write it as an ordered pair. That would be 0, 4. Okay, so likewise, this is an example of a horizontal line, right? There is no x-intercept, but there is a y-intercept at 4, right? And this is your horizontal line. Okay, number 4. Find the slope of the line containing the pair of points. Now remember, slope, the formula is just the change in y over the change in x, otherwise known as rise over run. But we can just take our 2 points here and subtract the y values. So that would be what? -5 minus -1, and 11 minus -6. Make sure you just work in the same order. So if I start with -5 for the y, then I need to start with 11. Start from the same point. All right, that gives us -5 plus 1, and 11 plus 6. So we get -4 over, is that 17? That is my slope. -4 over 17. Now remember, if you happen to get, this is just another example, if you end up getting a slope where you have like -4 over 0, this, right there, that is an undefined slope. Undefined. This is actually a vertical line. Okay, do not mistake this and say that that equals 0. It doesn't. If you happen to get 0 in the numerator, right, this actually equals 0. Okay, because 0 over 4 is the number 0. This is a horizontal line. Okay. 5 and 6, I put these together because these are examples of vertical and horizontal lines. Now remember, if you have a line that has an x and a y in it, you know that that line is sloping, sloping either up or down. But when you have only an x or only a y, right, you know it's either vertical or horizontal. Now in my notes, if you followed along, I gave you some memory pegs, and I'm going to write it right down here. Hoy, right, and Vux. Wish it were a little bit easier to come up with something, but Hoy and Vux. Okay, this first one, this stands for a horizontal line. The 0 is what the slope is. So a horizontal line has a 0 slope. And the y means y equals a number is the equation of a horizontal line. So every horizontal line is in the form of y equals, only a y. Okay, that is Hoy. Okay, V-U-X. Okay, the V is the vertical line. Okay, the second one is talking about the slope. The slope is undefined. That's the U. Undefined slope. And then finally, the equation of a vertical line is in the form of x equals some number. So once again, it's just a memory peg, but it helps for problems like number 5 and number 6. So given the equation, this is number 5, given the equation of the slope, given the equation of the line, find the slope. So when you look at this line, there's only an x. If you want to, you could solve it in terms of x equals. Right, we just divide out by -5 and we get x equals 14/5. Okay, but this is where you go down to your memory peg. If it's in the form of x equals a number, that is a vertical line. All vertical lines have undefined slopes. Undefined. All right, so that would be our answer. Likewise, let's look at number 6. We have the line -3. There's only a y. So if I were to solve that in terms of y equals, you really don't have to do this because all they're asking for is the slope. But if I did, that would give me y equals 20/3. Okay, but it's in the form y equals, which is over here. That means it's a horizontal slope, and all horizontal lines have a slope of 0. Let's move on. Number 7, given the equation of the line in standard form, determine the slope. Okay, they're wanting us just to practice transferring. This is standard form when you have the x and the y over on the left side. But if you were to convert that to y equals mx plus b form, right, that's called slope-intercept form. We know that your slope is m. and b is your y-intercept. So in this case, let's just take the line in standard form. We just want to solve it for y. So we'll get y equals. So you can subtract both sides. 2x, 3y. There. And then finally we want y equals. So let's divide out by 3. Once again, if you divide by 3, you have to divide everything by 3. And that gives you y equals negative 2/3 x plus 13/3. This is the same line as what was given to you. It's just two different forms. But when you put it in that form, you know that the slope is the number that's right in front of the x. So in this case, my slope is negative 2/3. Okay, number 8, find the equation of the line passing through the points. Write the equation in slope-intercept form. So for this, whenever they ask you to find the equation of the line, we use the point-slope formula. And that is y minus y1 equals m times x minus x1. Now, m, of course, is the slope. And then the point x1, y1 is the point that you're going to use. So basically, you need a slope and you need a point in order to find the equation of a line. Well, they give us 2 points, which is good, so we can use either one that we want to, but we do need to find the slope. So let's first find slope, and we know that that's the change in y over the change in x's. So that would be, let's see, we'll say 4 minus 2. Here's our points up here. 4 minus 2 and negative 1 minus 1. That gives us 2 over negative 2, which is negative 1. All right, that's our slope. So we need a point. Our point, I'm going to pick either one. I'll pick the point 1, 2. You can pick negative 1, 4 if you want to. We should get the same answer. And my slope is negative 1. Okay, we're going to use our point slope formula, so let's plug it in. Do it right here. Y minus, and 2, let's pick the y, right, from our point, equals the slope times x minus the x from our point. Okay, so that's the equation of the line. They just want to write, they want us to write our answer in slope-intercept form, which is y equals mx plus b. So let's solve this for y. So remember this, let's just multiply this through. We get negative x plus 1. And then we can add 2 to both sides. So finally, we get y equals negative x plus 3. That is our answer. So number 9 and 10, on the review, they're asking if the following graphs are represent functions. And this is wanting us to use the vertical line test. Very simply, for number 9, if you draw a vertical line anywhere on the graph and it touches more than one time, which in this case it does, that means it is not a function. So number 10, it's a small graph. Let's see if we can zoom in. But if you drew a line anywhere on here, if you notice it only touches one time. So this is a function. So the answer would be yes. Okay, so for 11, 12, and 13, we get to the find the domain questions. We had 3 different kind of functions we looked at, and this is an example of each one. So let's look at 11 first. This is called a radical because it has that radical sign, which is the 4th root. So when you get to this kind of question, you do need to first look and see, is it an even radical or is it an odd? Now, if it's an odd one, like a cube root or 5th root, there's really no problem. The domain is everything, okay? But when you have an even one, which here it is, it's the 4th root, the step you have to take is you take what's underneath the radical, which would be 4 minus x. All right, you set it greater than or equal to 0 because it needs to be positive or it could equal 0, and solve. That'll be your answer. So if you solve that, I'm going to take the x over to the other side. If I add it to the other side, I get x less than or equal to 4. Now, I wish that's the answer, the way we could put it, but they're going to ask for it in interval notation. So be really careful. If you drew it out we have the number 4. This is basically saying x is everything smaller than or equal to, right? So if you draw it out, you can kind of see how it'll work. In interval notation, we go from negative infinity to 4, and make sure you put a bracket because it is equal to. So this is how you type your answer. Okay, number 12, the domain. Find the domain of this function. Well, this is just a polynomial. We like polynomials because they're just super easy. Basically, the domain is everything. Everything works. So we would write that negative infinity to positive infinity. You can plug any number into this function and get a defined number. Okay, number 13. This is the rational. The rational, where you have a fraction. Whenever you have a variable in the denominator, you do need to worry about what makes that denominator 0, because it is not defined to have 0 in the denominator. So to find the domain, you just want to worry. It really doesn't matter about the top. You're just worried about the bottom. We want to solve the bottom for 0 and see what you get. So this factors x, and let's see, 45 is what, 9 times 5? And 9 minus 5 is 4. So it factors. So you're only worried about the denominator. Set each factor, so I don't have much room. Set each of those equal to 0 and solve. You get x equals negative 9 and x equals, x equals 5. I need to erase that. So if you notice, you've got x equals negative 9, x equals 5. Those are the two values that make the denominator 0. Therefore, the domain cannot be negative 9 and 5. The domain is everything but those numbers. Okay, so if you were to draw it out, here you have negative 9, and here's 5. It cannot be those numbers, but it's everything else. Look, they're going to ask you for this in interval notation, so sometimes it helps to draw it out. But the way we would write the answer for this, we always start from least to greatest, right? That goes from negative infinity to positive infinity. So the first interval would be negative infinity to negative 9, but it doesn't include 9, or negative 9. Then our next interval is negative 9 to 5. Doesn't include that, and then 5 to infinity. And there we go. All right, so here we get to this problem. This is probably one of the main ones that most students have trouble with or want me to work. And I think the problem on your test will look very similar to this. So let's just pay attention. So we just want to take it in steps. I'm first going to find, this is what they're asking for, to plug it into that formula. So we first are going to find f of x plus h. So let's do it right here. So f of x plus h. So you take the function f, here's our function, right? The function f is 8 times something squared minus 5, right? But instead of x, we have x plus h. So we plug x plus h into our parenthesis. This is f of x plus h. Now we have to multiply this out. So this is the longest part of the problem, of the question. So we have x plus h, We need to FOIL this out. That's first, outer, inner, and last. The only thing that really can be combined right here is xh. That gives you 2xh. Right? And then one more step. Let's multiply the 8 through. We have to distribute it through. That's what, 8x squared plus 16. Now make sure you do this. A lot of people will work it through and they will forget to multiply that 8 all the way through. They'll only multiply it by the x squared. That'll mess up your answer. Okay, so f of x plus h. This is the longest part of the problem. It's supposed to be long and drawn out, but now we can stick it in to our formula here and things ought to shrink. Okay, so let's do that. So we have f of x plus h minus f of x over h. So So I'm just going to copy it down. F of x plus h is right above me. I'm going to recopy it. All right. Minus f of x. Well, f of x is easy. Remember, that's given to you in the problem, and that's just 8x squared minus 5 all over h. Okay, so if you look in the numerator, you have a subtraction. Make sure you have to distribute that negative through. But I will tell you, everything in these last two terms, 8x squared minus 5, those should subtract off with something earlier in the f of x plus h. So let's do it right here. I'm going to take an extra step where I distribute. You want to drop your parentheses, but just make sure. Oh, sorry, that should be minus. Okay, so that's f of x plus h. Let's distribute that negative through. That's negative x squared plus 5. All right, so like I was saying, you have 8x squared minus 8x squared, that's 0. Negative 5 plus 5. See, so things start shrinking. So you have 16xh plus, see, it's smaller. You're almost done. One last thing, you can cross out common h's. Let's do it right here. I can factor out an h in the top, and that leaves me 16x plus 8h. Those cross out. Your answer is 16x plus 8h. Okay, let's look at number 15. This is a piecewise function. It's just a basic question. They're wanting to show that you know how to evaluate it. So look at A. We want to find f of negative 3. So our x is negative 3. You just want to go up to the piecewise function and find where negative 3 falls. And it falls right there because negative 3 is less than 0. So that means you're going to use the top part. You're going to plug in negative 3 to 5x plus 5. And then whatever you get for your answer is your answer. So I got negative 10. So f of negative 3 is negative 10. Then I asked for f of 0. Well, 0 up here should fall only one place. It falls here because it's equal to 0. So I'm going to plug 0 into 3x plus 7. You plug in 0, you get 0 plus 7 is 7. Okay, so that's just your piecewise function. So now we get to graphing and looking at parabolas and quadratics. So remember, we had two ways that we would write the quadratics. The first one is the vertex form, and that's right here. Okay, the vertex is easy, and when it's in this form, you can look at it and tell. So remember, your vertex is an x and a y. Your x is right next, is the x minus 4. It's the opposite, so we'll pick positive 4. And then for your y, you keep the sign with the 9, so it's going to be negative 9. So just remember, the x, you take the opposite of x minus 4, which gave you positive 4, but you keep the sign with negative 9. And that's your vertex. And then they're going to ask you for the x-intercepts. Remember, x-intercepts, you let, like always, let the opposite be 0. So let y equal 0. Solve for x. Okay, y is f of x, so that's 0. And now we just have to solve for x, so we're going to use the square root property. Let's clear 9 to the other side. That gives us 9 equals x minus 4 squared. So now we can take the square root. The square root property says if you take the square root of both sides, you must include plus and minus. So that's positive and negative 3. And this cancels. You get x minus 4. We're almost there. I'm going to add 4 to the other side. Right? So that would give me 4 plus and minus 3 equals x. So that means we have 4 plus 3 and 4 minus 3. So my x-intercepts are 7 and 1. Now they want you to write it as an ordered pair, so we would write it as 7, 0 and 1, 0. But that's how it works when you have the vertex form. Let's look at, let's see, number 17. This is the same thing except it's in standard form, if you notice. It's not the vertex form. All right, so for this one, finding the vertex requires a little more work. So if you remember, for the vertex, you have an x and a y. Okay, the x is a little small formula. It's just negative b over 2a, and that's how you find your x value. So let's look at that. We have b in this case. You know, we have, let's see, a is 1, 2 is what comes out in front of the x is your b. All right, so we have negative b, so it'll be negative 2 over 2, and a was 1. So we got negative 1. That's the first part of your vertex. Okay, so now once you find that, to find the y, you're just going to take negative 1 and plug it in for x and see what you get. Because remember, this is your y. Okay, so we have negative 1 squared. Be careful, you're squaring negative 1, so you want to square it. That'll make it positive. 2. See, I'm just plugging it into the formula, the function. That gives me 1. And 2 times negative 1 is minus 2. So we have 2 minus 2 is 0. I get y equals 0. All right, so what are we looking for? My vertex is negative 1. My y was 0. It's my vertex. So the x-intercepts, basically, we let y equal 0. Okay, that's f of x is 0. And it should factor. Hopefully it will. See, that's plus 1 plus 1. All right, so we solve each one. Negative 1. We get negative 1 twice, so you really only have one x-intercept. Okay? So the x-intercept is or are, since there's only one, we have negative 1, 0. But you very well could get two different ones there. This just happened to factor into the same factors. Okay, for 18, this is operations of functions, whether you're adding, subtracting, multiplying, or dividing, or composite functions where you stick one function inside the other. So for this one, and on the review, we're skipping a few of these problems because they're asking you just some separate ones, whether you're either multiplying or dividing, but it all works the same. So I'm just going to look at number 18. So this is just a way of writing it. F minus g of 10 is basically saying we're going to subtract f and g. Right, so that'd be f of 10 minus g of 10. And the 10 is obviously what they want your x to be. So you're going to plug 10 in for x. But this is just telling you to subtract f and g. I could have easily given you plus where you add them, or dividing, or multiplying. Okay, so let's find f of 10 first. So to find f of 10, you come up here to your f function right there. I'll do it right here since we have plenty of room. It's square root, and just plug in 10 everywhere you see x. Square root of 9, and that is 3. So f of 10 is 3. And do the same thing with g of 10. Except you got to use the function g, which is right there. So what is that? 10 squared minus 10. Minus 10. It's 90. So g of 10 is 90. So you're just going to subtract them. And so you would have done the same thing if I had asked you to add. You would just add the two numbers. So 3 minus 90 gives you negative 87. And there's your answer. There's lots of these in the review to work, and you could be asked a few of these on your test. All right, here we get to the composite function. You see this little small circle, f of h. That's not multiplication. It stands for composite, where you stick one function inside of the other. Okay, so when you have f with the little circle of h, you can rewrite it this way. Okay. So this might make more sense. You're taking h of 5 first, and you're going to plug that into f. So we want to find h of 5 first. And we go up and we find our h. Our h is the, square root of x plus 4. And plug in 5 for that. So that would give us square root of 9, which is 3. Okay, so h of 5 is 3. And now we can find f of 3. So 3 becomes our new x. So we plug in 3, f of 3. Let's see, our f function is 5x plus 1. And that gives us 15 plus 1 is 16. And that's my answer. 16. Sorry, that's messy. Okay, let me just show you though. A lot of people like to write it this way from the beginning. If you have it in terms of a little circle, you can think of it this way. You're going to work from the right and go backwards to the left. So if you start x is 5, you're going to plug 5 into h. Okay, which we did. We found h of 5 and we found it to be 3. That was our answer. Now we take 3 and plug it into f, which we did, and we found 16. Some people just like to use that notation. I personally like it too. So let's try it for 22. Okay, so let's see. See what I'm talking about? If you have h of f of negative 2, this time our x is negative 2. If you want to use the notation, you take negative 2 and you plug it into f first. Okay, so let's do that. Let's find f of negative 2. And let's see, f is what? Negative 3 x minus 1. So let's plug in. See what we get. We get 6 minus 1 is 5. So we get 5. Okay, so when we plug negative 2 into f, we got 5. Sorry, that's kind of messy. Now 5 becomes our new x. Okay, so 5 comes down. We're going to plug 5 into h now and see what we get. Or if you look over here, take 5, plug it into h. Either way, you're finding h of 5. So let's go up to our function. Here's our h. It's negative 4 over 5 plus 1. Is that negative 4/6? And let's reduce it. We can take out a 2, negative 2/3. And that's my final answer. Okay, for 23, obviously this has 4 parts, but I'm just going to do A and D just for time's sake. Okay, here we have, this is what we're continuing what we've been doing. It's just using a graph this time. So we're looking for f plus g of 2. That's f of 2 plus g of 2. We just want to find each of these separately and then we'll add them together. So using the graph, to find f of 2, 2 is your x value on your x-axis, right? F of 2 is what your y value is. So I'm going to kind of zoom in a little bit. And let's look at it. Let x be 2. So when on the x-axis, when x is 2, go find f of 2. So f of x is the blue graph. So we have the point about right here. Right, 2, 4. Okay, f of 2 is the y value. So the y value would be 4 in that case. Okay, now g of 2, same thing. This represents x, right? Okay, so when x is 2, find the point on the g graph, which looks like it's right there. And your y value is your answer, so that would be 0. So I have 4 plus 0 is 4, and that's my answer. So I'll zoom back out. There we go. Okay, so let's do D. You can do it for all of them. We'll do D. Let's see, this is dividing. So this would be f of negative 1 divided by g of negative 1. Let's just find them separately and we'll divide them. So let's first find f of negative 1. So once again, let me zoom as best as I can and still have everything on the page. Okay, f of negative 1. X is negative 1, right? So here we have negative 1. And let's find it on f. That would be right there. And that the y value is positive 1. There. And then g of negative 1. Here we still have x is negative 1, but g is the pink graph. That would the point would come down there, and that would be at negative 3. So 1 over negative 3 is negative 1/3. Okay, for 24, you see you have A all the way through F. We're just going to work a few of these. Let's start with A. We'll do A and then we'll do maybe either E or F. Let's see. So let's look at A. I'm going to just copy it down here. F of G of 1. This is using the composite function, but using the graphs. So remember how we did that? We said that we can take 1 and plug it into, well, let's do it this way. 1 and plug it into G. Okay, so that means we're going to find G of 1. My X is 1. So when X is 1, zoom. When X is 1, what is my Y? Go find it on the G. The G is the red. So we have, here's my point. My Y value is 2. Right? Now 2, that's what we got there. So we plug 1 in, we got 2. Now we're going to take 2 and plug it into F. So think about it. 2 becomes our new X value. Just got to remember it that way. 2 becomes our new X. So now, still looking for X. 2 is on the X-axis. So 2 would be right here. Let's see. F is the blue. So at 2, you have the point. 2, negative 2. So the Y value is negative 2. And then you're done when you can't go any further. All right, so let's recap over here. We plugged 1 into G and we got 2. Then we turned around and let 2 be our new X. Plug 2 into F and we got negative 2. Negative 2 is my answer. Okay, now let's look at, let's see, why don't we do F? We'll just pick one. Since it's got 3, I wanted to do either E or F. We'll do F. Okay, so let's look. We have G of F of G. Kind of weird, but remember, when we use this little notation with the backwards arrows, we're going to work from the right back towards the left. So let's first plug 0 into G. See what we get. G of 0. Remember, your X is 0. So zoom in. When X is 0, what is G? Well, it looks like it touches right there. So that's 0. Okay, so now 0 becomes my new X, and I'm going to plug it into F this time. Move up. So F of 0, so like X is 0, so when X is 0, where is it on F? You go down to the blue graph. There's my point. It's 0. That's right there. My Y value is negative 2. Right, negative 2. Now one more time. Now we're plugging negative 2 back into G. Okay. Now X, negative 2 becomes our new X. So come over here to the graph, go to negative 2 and find it on G, which would be right there. Which that's at, the Y value is negative 4. And there's our answer. So to recap, we took 0, we plugged it into G, and that gave us 0. 0 became our new X. This time we're plugging it into F. Look, find it on F, and we got negative 2. And lastly, now let's take negative 2 and plug it back into G. And this time we got negative 4. And when we can't go any further, we're done. So my answer is negative 4. Like I said, I just picked 2 of these for time's sake, but this is how you work all of these. Okay, so we get to finding the inverse function. Well, we had 3 kind of problems that we saw that we found inverse functions. One is a line. Now, I'm not going to work one of these today, but I will work the other 2. So this one involves when you have a 5th root, and they want you to find the inverse function. So if you remember the inverse function, there's 3 quick steps. The first one is you're going to put the y back into the function. So replace f of x with y, which it means the same thing. Okay, that's the first step. Second step, you want to switch your x and y's. So everywhere you saw, everywhere you saw a y, you put an x, and an x, you put a y. Okay, so this actually is the inverse function, but they want you to write the answer in terms of y equals. So we have to solve this for y. So when you have the 5th root, we're going to end up, we want to raise it to the 5th power. So we want to get y by itself. So let's clear 5 to the other side. X minus 5 equals negative 5th root. Okay, we want to raise it to the 5th power, but I really don't want to do it with this negative. So let me get rid of that negative. You can think of it as a negative 1. So the quickest way is you can divide out by -1 each side, and that gets rid of it. That leaves us, I'm going to take -1 out of each one, so that would be -x plus 5. And you're welcome to rewrite that. You know, -x plus 5 is the same as 5 minus x. It doesn't matter which way you write it. You certainly could do that though. Okay, so now we have the 5th root by itself, which is what we wanted. So to get y out from underneath the little radical sign, we can raise it to the same power, but we have to do it to both sides. Right? These cross out and just give you y minus 7, which is great. Once again, here we are. Finally, we want y by itself, so we can add 7 to the other side. So that would be -x plus 5 to the 5th plus 7 equals y. Okay, that's your inverse function. This y is now a new y, so you could write it y inverse, or you could label it f inverse, since it's the inverse function of the original f. But this is what they're going to want you to type in for your answer. Okay, 26. This is still find another inverse. This is the other one that we saw, which was a rational, where you have a fraction, you have x in the numerator and the denominator. You definitely will see one like this, so let's work it through. So remember our steps. First step is we want to put the y back in. So replace f of x with y. And then the second step is you want to switch your x and y's. Right? So we have, you know, anywhere you see a y, you put an x, and an x, you put a y. Okay, 7y. And now you just need to solve it. We're going to solve it for y equals. Okay, so when you have the fraction, the first thing we want to do is get rid of that denominator. And the quickest way is you can multiply both sides by the denominator. Multiply both sides by 7y plus 3. That's a 7. This allows us to be able to cross out our denominator. And I'm going to rewrite it, but I do want to distribute the x through. So I get 7xy plus 3x. And no more do I have fractions, which is nice. Okay, but we're still got to solve for y. If you notice, there's two terms that have y values. So in this case, let's bring all the y's to one side and group them together. Clear everything to the other side. So I'm going to bring my 4y to the left. That would give me 7xy minus 4y. And then I want to clear 3x to the other side. So that would give us negative 3x minus 5. Okay, but I have my y terms grouped together on the left side. And now from here, these can't be combined, but you can factor out a y. And this is what you'll want to do. So take out a y. You get 7x minus 4. There you go. And now when you have it in this form, you're almost done. Since they're being multiplied, you can divide out by 7x minus 4. Cross them out, and you get y equals, and this is your inverse function. It works this way every time. The numbers might be different, but this is how you work it. Now remember, this y, it's no longer just y, it's inverse y. F inverse. But this is what you'll plug in for your answer. Okay, we're down to our last problem for today. I think there's 2 of these on the review. I just chose one to work through. So let's first go through this. This is the polynomial and trying to pick out a rough sketch of a polynomial. So let's first start with the end behavior. The first question is find the left and the right end behavior. So for this, we look at the leading coefficient, which for our function here would be x to the 4th. I'll put it over here. Okay, so if you remember x to the 4th, the order that you look at it, you first look at the coefficient, which in this case is positive 1. It doesn't matter what the number is, it just matters whether it's positive or negative, and that tells you how the function ends to the right. And so if it's positive, it ends going up. So we would say the right-hand behavior is up, like that. And then you look at the degree, which is 4 in this case, so it's either going to be even or odd. So remember, if it's odd, it means it goes in the opposite direction, but this one is even, and even means the same. So that means since the right-hand behavior was up, that means the left-hand behavior is up also. Right? So it's basically going to kind of look like this on the ends. Now, if you look down at the very bottom where you have to choose your graphs, if you notice there's only one graph that has the end behavior both being up, which is that one, which is kind of nice. You can actually pick out your graph on Pearson. The way it works is, I think everyone I've seen, you've been able to cross out, you know, with the end behavior, you can eliminate the rest of them. So that's nice. But that doesn't come up until the very end. So now let's look at the y-intercept. Okay, find the y-intercept. Remember, you let x equal 0, like always. And you're plugging 0 into the function. So that would be f of x, or y, is 0 to the 4th. Plus 2 times 0 cubed, minus 15, 0 squared. Sorry, that's kind of messy. That's basically 0 plus 0 minus 0. You get y equals 0. So your y-intercept is 0. This is the only place in Pearson on this test where they let you just put the value for the y-intercept and not have to write it as an ordered pair. So y was equal to 0. Okay, now let's look at the zeros. Or the real zeros is the same thing as the x-intercepts, just a different name. So if you're looking for your zeros, right, you just want to factor the function. You let y equal 0, which is f of x. If you let it equal 0, you need to get this thing factored. And then solve that, and that will give you your zeros. Okay, if I factor it and bring out an x squared, that leaves squared plus 2x minus 15. And look, this should be able to factor for you, okay? 5 times 3, so it did factor. Okay, so if you're solving that, you have 3 possible zeros. For the first one, x squared equals 0, you just set it equal to 0. You get x equals 0, right? This one would give you a negative 5, and that one would give you 3. So these are what we call our zeros, which are also our x-intercepts. So the real zeros of the polynomial are 0, negative 5, and 3. It doesn't matter what order you write them, but that's the answer for that. Okay, this whole thing about multiplicity is kind of interesting. It's just one little thing that you can look at to figure out a little bit about the graph. So the way you find multiplicities is you come over where we factored, you take each 0. So let's start with x equals 0. Go to the factor, which was right here, that gave me 0. The power, or the exponent, is your multiplicity. So in this case, since x is raised to the second power, 0 has a multiplicity of 2. I'm going to write it right here, multiplicity 2, right underneath it. Likewise, look at for negative 5. Here's your factor is x plus 5. And notice the power is an understood 1. So the multiplicity of negative 5 is the exponent, which was 1. That's your multiplicity. And the same thing for 3. You go up to the factor, which was x minus 3, and it had a power of 1. So 3 has a multiplicity of 1. All right? So sorry that's kind of scribbled over there, but hopefully that makes sense. So 0 has a multiplicity of 2, and then the other 2 zeros both have multiplicity of 1. The way that Pearson makes you type this in is they'll say the multiplicity of the 0 located farthest to the left on the x-axis. So just make sure, we've written them out of order, but if you were going to graph it on an x-axis, negative 5 is farthest to the left. And that's the way they have to ask it, because they can't give away that 0 and negative 5 were zeros. So that's how they'll do it. So the multiplicity of the 0 to the farthest to the left, we're talking about negative 5, and we found that negative 5 has multiplicity 1. The multiplicity of the 0 located between, which would be 0. Remember, 0 had multiplicity 2. And then the one farthest to the right would be 3, which has multiplicity 1. Okay, so that's how you find the multiplicities. So now they want us to evaluate a test point. Find the value of y at x equals -4. So they're just wanting you to plug in -4 for x. So let's find this. Let me get my right. Got to get my pencil. Okay, so we have f -4. That gives us -4 to the 4th. It's 2 -4 cubed. If they ask this, you know, you won't have graphing calculators, you'll have plain calculators. So just be careful. I'd calculate it just in steps. So -4 to the 4th is 256. Let's see, -4 cubed is -64. And then we know -4 squared is 16. So we have 256 minus 128 minus and 15 times 16 is 240. So if you add, subtract all that together, you get -112. So that's your answer. Okay, and once again, when you get to this part, you can choose your graph. Really from the end behavior, but you can double check the zeros. If you notice, the zeros were 0, -5, and 3. Let's see. -5, 0, and 3. They both ended going up. And when you were -4, you got a point way down here at, you know, what, -112. So that all makes sense. And that's how you go through working 28, I think 27 and 28. Okay, that's it for today. I hope that this has helped. Please don't hesitate to email me if you have any questions. Good luck on your test.